Learned last week, and you're going to have two questions on your quiz about this today. The most of the quiz is Pythagorean theorem and radicals, but you're going to have two questions about acute, obtuse, or right on your quiz today. I was asked about number 25. It's not the toughest one from this section, but I'll do it. You need to first identify which one is C, which one is the largest. The next step that you're going to do is you're going to write Pythagorean theorem, but you're going to write it backwards. We're writing it backwards for a certain reason, okay? Then we're going to solve it. C squared, and then A squared plus B squared. Then we're going to give it an inequality, a greater than or less than or equal to sign. The sign is going to eat, it's going to open up to the larger number. It's like it's eating the larger number. Then you read the sign. You always read from left to right. This is a less than sign. So since it's a less than sign, our triangle is acute. When it's a greater than sign, our triangle is obtuse. So less than, acute, greater than, obtuse. So that's what makes this one acute. Do you want me to work any others from this section? 14 is from just the mixed review part. Oh, you know what? Today we are going to learn a shortcut to solve this one. I will set this one up for you, but I'm not going to solve it completely, because we are going to learn this great shortcut. So technically on this one, you would want to name these a letter, like name it A, all the sides are A. So if you're looking at this right triangle, you would do A squared plus A squared equals 11 root 2 squared, okay? Because it's a square and all the sides are the same letter. Don't name one of them X and one of them Y. Name them both the same letter. So this is 2A squared equals, be careful, that's 11 squared times square root 2 squared. Remember, you have to square both terms. Very important. Let's see, what is that? 121 times 2? I guess I am going to solve it because it's not that bad. Well, when you end up dividing both sides by 2, we're kind of introducing today's lesson actually. A squared, we're back to this. A squared is 121. So A is the square root of 121. What's A? 11. It's 11, 11, 11, 11. So now we would look at this triangle right here, and we would do Pythagorean theorem. 12 squared minus 11 squared equals x squared. So 144 minus 121 is 23. So x is the square root of 23. And that is a really good introduction to today's lesson. Do you want to do any more homework before we go on to today's lesson? 29 is a very important problem that you will see again in the future. This right here says AC is parallel to FG. So we can add arrows to our picture because we know that it's parallel. What we're going to do first is we're going to look at this triangle. And what we're going to do is we are not going to assume it's a right triangle. Is everyone listening? We are not assuming that's a right triangle, even though it surely does look like one. So since the jury is out and we don't know what kind of triangle this is, we're going to use Pythagorean theorem converse. And we're going to find out what kind of angle angle D is. So we have 625 and we have 612. 625 is greater. C squared is greater. So this angle right here is obtuse. Now it's asking about the measure of angle 1. Is angle 1 acute, obtuse, or right? It's not asking about angle BDC. So now we need to remember what's true about parallel lines. Remember, if this angle is obtuse, let me draw it kind of obtuse. That is corresponding with this angle. That means this one is also obtuse. And then that angle and angle 1 make a linear pair. Well, if I had a linear pair and one of my angles was obtuse, what would the other angle be? It would have to be acute. Another way to look at this is this angle and this angle are same side exterior angles. Same side starts with an S. That means that angle and angle 1 are supplementary. If two angles are supplementary and one of them is obtuse, well then the other one has to be acute. So the answer to number 29 was acute.